In September 2002, environmental workers wearing protective gear sealed off a dangerous pond with caution tape. Another team was already waiting in boats, preparing to head toward the middle of the water. Under government orders, they began pouring containers of a strange liquid into the pond. Less than an hour later, long, dark-colored fish began floating to the surface. One appeared, then another. Soon the water was covered with dead fish. The liquid was in fact a poison that prevented fish from breathing underwater. Officials believed they had no choice but to use it to completely eliminate the species the media had called America's most dangerous invasive fish. Collection crews found 6 adult snakeheads, along with more than 800 juveniles measuring about 4 inches long. In total, more than 1,200 fish were removed from a pond where just a few months earlier, almost no one had known they existed. Authorities declared the operation a success, but 2 years later, hundreds of snakeheads appeared in another, much larger river system. By 2011, there were days when the water seemed to be filled with them. Juveniles crowded the shallow areas, while adults hid beneath thick mats of hydrilla like submerged logs with teeth. But recently, something unusual happened. After 12 years of working with the Maryland Department of Natural Resources to conduct electrofishing surveys, estimate populations, and track this invasive species, John Odenkirk noticed that the snakehead population's rate of growth was slowing. In some areas, the number of adult fish had stabilized and had even begun to decline. There had been no additional eradication campaign. There was also no technology capable of eliminating every fish from such a vast river system. So what happened? This is the story of an invasion that lasted for decades, costly control measures, and a turning point that scientists are still trying to explain. The information used in this video was compiled from the USGS, USFWS, the Maryland DNR, the GAO, and published fisheries research. To understand what is preying on snakeheads, you first need to understand why the United States once feared this fish so much. Between 1997 and 2002, around 50,000 live northern snakeheads were legally imported into the United States. However, they were still an invasive species. In China, South Korea, and Russia, they are commonly eaten and valued for their firm, white, slightly sweet meat, which is high in protein and tough enough to withstand high-temperature cooking without falling apart. Then, sometime in 2002, someone released several of them into a stormwater retention pond in Crofton, Maryland. No one knows who did it. From that small incident, snakeheads quickly became a symbol of America's invasive species crisis. One striking example occurred in the Blackwater River system, where 19 of 22 fish species disappeared after snakeheads arrived. This is not difficult to understand when more than 97% of an adult snakehead's diet consists of other fish. In October 2002, the entire snakehead family was classified as injurious wildlife under the Lacey Act, banning the importation and interstate transport of live fish without a special permit. Soon afterward, authorities introduced a series of aggressive measures. They sealed off newly invaded waterways, used electrofishing boats to stun the fish so they could be collected, and urged the public to kill any snakeheads they caught. To make sure none remained, they also carried out operations like the one you saw at the beginning. Maryland authorities poisoned the Crofton pond with rotenone, recovering 6 adult snakeheads and more than 1,000 juveniles. But in my view, this method also carried significant risks. Rotenone did not kill only snakeheads. It also wiped out many native fish species living in the same body of water. And if even a few snakeheads escaped into a nearby drainage ditch, wetland, or river branch, the entire operation could become meaningless. That concern quickly became a reality. Over the next 2 decades, snakeheads continued to appear throughout the Potomac River system, the Delaware River Basin, and many tributaries flowing into the Chesapeake Bay. While authorities were still trying to figure out what to do next, resourceful boat owners turned snakehead hunting into part of Maryland's fishing culture. Bow fishing tournaments began to appear. At night, boats equipped with powerful lights sweep across the shallow water when the fish rise to the surface to breathe. This method is especially effective because snakeheads often hide in places that are difficult to reach with nets. Between 2022 and 2024, 556 bow fishing trips were recorded across 17 rivers. Each trip lasted nearly 5 hours and could bring in as many as 32 fish. In June 2025, One specimen weighing 21.8 pounds even set a new state record. The fish was once known as the Frankenfish, but in an effort to attract participants from around the world, Maryland renamed it the Chesapeake Chana in 2024. However, this is not an effective long-term solution. By 2026, bow fishing and spearing accounted for only about 20% of the population's mortality rate, still below the 25% target needed to produce a steady decline in numbers. So why, after more than 2 decades of continuous hunting and control efforts, has this fish continued to survive and expand its range? That is what we will discuss in the next section. Put simply, evolution built them like an emergency survival plan. Seriously, this may be one of the strangest creatures you will ever encounter. Native to the cold rivers of northern China and eastern Russia, the northern snakehead evolved in harsh environments where ponds could dry up, oxygen levels could collapse, and freezing winters could wipe out weaker fish species. So the snakehead found a way to cheat. It possesses a suprabranchial organ, a primitive air-breathing structure that works almost like a lung. When oxygen levels drop, the fish rises to the surface and gulps air directly from the atmosphere. If the pond dies, the fish does not necessarily have to die with it. It can simply leave. Early reports of a fish that could walk on land were exaggerated, but they were not entirely false. Snakeheads can twist and crawl across wet ground for surprisingly long distances, especially during rainy weather. They use powerful side-to-side movements to push their bodies toward a new body of water. Once they reach it, they reproduce aggressively. A mature female can carry as many as 50,000 eggs and may spawn several times from late spring through summer. Under suitable temperatures, the eggs can hatch in just 24 to 48 hours. Unlike many fish species that abandon their eggs after spawning, both the male and female remain behind to protect the nest and their young. They patrol around the school of juveniles, charge at any creature that comes too close, and continue guarding them until the young fish are large enough to feed on their own. While the impact in the Blackwater River was becoming increasingly concerning, the opposite pattern was emerging in the Potomac River. John Odenkirk and Mike Eisel of the Virginia Department of Game and Inland Fisheries used electrofishing boats to monitor snakehead populations in 4 tributaries for periods of up to 12 years. From spring through early fall, they traveled through shallow water less than 6.5 feet deep, collected the stunned fish, measured and counted them, and recorded how many were captured during each hour of surveying. At Little Hunting Creek, the boat traveled along both banks, covering nearly the entire tributary. Beginning in 2009, fish were also tagged and released back into the water to estimate the total population size. The results showed that adult densities had once reached approximately 12 to 22 fish per hectare, but declined for 3 consecutive years between 2013 and 2015. However, the research team could not identify a single cause. The available food supply may have reached its limit, competition among snakeheads may have increased, fishing pressure may have contributed to the decline, or part of the population may simply have moved elsewhere. As for the theory that native fish were beginning to fight back, direct evidence was still needed. The first candidate to attract the attention of observers was the bowfin. This is an ancient predator native to North America. Around 65 million years ago, when mammals were still small creatures hiding in forests recovering from the asteroid impact, bowfin were already patrolling the wetlands of North America. They survived that mass extinction. They survived the ice ages. They survived the arrival of humans. Yet for decades, anglers treated them like trash. Mudfish, trash fish, worthless fish. People killed them and left them to rot on the riverbank because they were not bass, they were not trout, and they had little commercial value. At the same time, wetland drainage, pollution in stagnant waterways, and agricultural runoff destroyed much of their habitat across the eastern United States. Then, slowly, conservation projects began improving water quality during the 2000s. Bowfin returned to rivers that had already been occupied by another predator with an almost identical hunting strategy. Bowfin and snakeheads are not closely related, but evolution has turned them into ecological reflections of one another. Both can breathe air. Both dominate oxygen-poor aquatic vegetation. Both ambush prey from cover. Both thrive in stagnant water where other predators struggle. And bowfin are fiercely territorial. An adult bowfin is not a graceful fish. It has thick scales, a muscular body, and scars covering its skin. Radio tracking research in the Potomac found that snakeheads moved into water averaging only about 3.1 feet deep before the spawning season. During the breeding period from June through September, they were most heavily concentrated in vegetation, growing in water about 2.9 feet deep. That is also the type of marsh and shallow bay where bowfin live, build nests, and protect their young. Two large predators need the same patches of shallow aquatic vegetation for spawning, hiding, and feeding, so it is entirely reasonable to believe they compete for space. But this remains only a hypothesis. No field study in the Patuxent or Potomac has documented bowfin repeatedly attacking snakehead nests, driving the parents away from their young, or reducing the survival rate of juvenile snakeheads. After the bowfin, the second opponent to attract scientists' attention was the largemouth bass. But here, the evidence takes the story in a more unexpected direction. Bass have not been confirmed to wait until snakehead parents let their guard down before rushing in and swallowing the entire school of young. In fact, the clearest study suggests that the two species mainly confront each other by competing for the same food. In 2012, Ryan Saylor and his colleagues at the U.S.G.S. published a study comparing the stomach contents of northern snakeheads with those of three predators living in the same area near Fort Belvoir in the lower Potomac. The three species examined were largemouth bass, American eel, and yellow perch. The results showed that more than 97% of an adult snakehead's diet consisted of fish. Among the three competitors, only largemouth bass had enough dietary overlap to be considered biologically significant. Both species consumed large numbers of killifish and members of the sunfish family. This made them competitors searching for the same prey in shallow coves and beds of aquatic vegetation. Largemouth bass use a highly effective feeding mechanism. When approaching a small fish, the bass rapidly expands its mouth cavity and lowers the bones beneath its head, creating low pressure that pulls water and prey into its mouth. High-speed video experiments have confirmed that bass can combine a forward strike with suction at the moment of attack. But no study in the Potomac has documented a single bass using suction to swallow 10 juvenile snakeheads at once. Nor is there evidence that bass regularly cut through schools of young snakeheads like a lawnmower in your backyard. Instead of proving that bass were eliminating snakeheads, a 2012 model raised the opposite question. Could snakeheads reduce largemouth bass populations? When snakeheads were present at only 10.6% of sites containing juvenile bass, the model predicted a bass population decline of about 3.8%. In a hypothetical scenario where both species were widely present together, the decline could reach 35.5%. This was a model-based prediction, not an observed population decline. After nearly 2 decades, the U.S. Fish and Wildlife Service concluded that the relatively healthy environmental conditions in the Potomac had allowed both snakeheads and largemouth bass to continue thriving without clear evidence that either species was controlling the other. The USGS has stated that some snakehead eggs may be eaten by insects and small fish after fertilization, but largemouth bass have not been identified as the primary cause. For now, the idea of a pincer movement involving bowfin and largemouth bass remains an intriguing hypothesis, not a proven discovery. Bowfin may compete with snakeheads for space, while largemouth bass clearly compete with them for prey. Incidentally, pressure from predatory fish is not the only factor determining the fate of the northern snakehead. A study by N.W.R. LaPointe, J.T. Thorson, and P.L. Angermeyer fitted fish in the Potomac River system with radio transmitters to determine where they took shelter during different seasons. The results showed that snakeheads were not distributed randomly. Before the spawning season, they returned to shallow water about 3.1 feet deep. From June through September, while building nests and protecting their young, they showed the strongest preference for areas only about 2.9 feet deep, with abundant aquatic vegetation and cover. After the spawning season, they moved into vegetation beds at an average depth of about 3.8 feet. Only in winter did they retreat into deeper water, averaging around 4.4 feet. Most notably, after the spawning season, snakeheads frequently selected beds of Eurasian water milfoil, an invasive aquatic plant that was already established in the Potomac. These dense beds create calm water, soft-bottom sediment, and dark hiding spaces where adult snakeheads can conceal themselves, ambush prey, and avoid fishing equipment. The study did not prove that Eurasian water milfoil directly caused snakehead populations to increase. However, it revealed an important pattern. An invasive species that arrives first can alter the structure of an ecosystem and unintentionally create favorable shelter for another invasive species that arrives later. Today, the fish continues to spread, so of course it still needs to be controlled. Beyond fishing and poison, however, there is another much simpler solution: eating it. That is also the strategy Maryland is encouraging. Before 2002, live snakeheads were sold at food markets and in some restaurants in Boston, New York, St. Louis, and many other major U.S. cities. Their meat is white, firm, and does not easily fall apart during cooking. Adult fish can grow quite large, and many people consider them delicious. So as snakehead populations expanded, wildlife managers began encouraging anglers to keep the fish instead of releasing them back into the water. Snakeheads can be harvested year-round, with no minimum size limit. The state also issues commercial bow fishing licenses, while the USFWS has stated that angler harvest may remove more than 25% of a local population, enough to place significant pressure on the number of fish. However, turning an invasive species into a commercial product is not easy. Once the fish becomes valuable to restaurants, fishing guides, and tournaments, some people may begin wanting the population to remain. An even greater risk is that live fish could be transported or released into new bodies of water to create additional fishing locations. This is why the Lacey Act prohibits the importation and interstate transport of live snakeheads without a permit. Fish sold for food must be killed before they are transported. USGS models have also warned that harvesting a highly reproductive species can sometimes trigger a compensatory response, allowing more juveniles to survive as the density of adult fish declines. To this day, northern snakeheads continue to expand their range and have now appeared across nearly the entire Chesapeake Bay watershed. Wildlife agencies acknowledge that complete eradication is no longer realistic. The practical goal is to reduce their density and prevent them from entering new bodies of water. However, the feared scenario in which this fish rapidly takes over every river in the eastern United States has not occurred evenly. In some Potomac tributaries, populations that once grew rapidly have begun to slow down and show signs of stabilizing under the combined effects of environmental limits and continued harvesting. But that does not mean the ecosystem has fully recovered. In the Blackwater River system, 17 of the 21 species recorded during both study periods declined in abundance, while fish communities at 5 of the 6 survey sites changed significantly after snakeheads became established. The northern snakehead has not completely won, but the United States has not been able to end the battle either. The two sides are entering a fragile state of balance that must be maintained through continuous monitoring and harvesting. This battle will not end after just 2 decades. It will continue for many more years, and snakeheads may never disappear from the United States. People have tried poisoning ponds, electrofishing, nets, fishing rods, bows, and spears. These methods can reduce their numbers in individual areas, but they are not enough to eliminate a species that has already spread throughout vast networks of rivers, wetlands, and tidal waters. What is especially important is that the consequences are not the same everywhere. In some tributaries of the Potomac River, snakehead populations increased rapidly before gradually slowing down. But in the Blackwater River system, many native fish species declined, and the structure of the fish community changed significantly. In the Patuxent River, the future remains uncertain. Fishing pressure may be helping keep their numbers under control, but it is also possible that snakeheads are simply spreading into new waters. Floods, connecting canals, and the transportation of live fish could continue opening new pathways for invasion. What do you think? Should people continue trying to eliminate snakeheads, or accept that they have become a permanent part of America's ecosystems? Share your opinion in the comments below. And don't forget to subscribe to the channel as we continue exploring more incredible stories from the natural world.